Hello students, the next topic is invariance or covariance of Maxwell's equations in terms of 4 vector. Covariance of Maxwell's equations. So Maxwell's equations can be expressed in 4 vector form. This is called covariance, and these Maxwell's equations are invariant. They are same in any of the inertial frame of reference. Our aim is to write down the Maxwell's equations in 4 vector form and prove that they are equal in 2 different inertial frame of reference. This is the meaning of invariance or covariance of Maxwell's equations. What are the 4 Maxwell's equations? Divergence of D is equal to rho, divergence of B is equal to 0, del cross B is equal to minus dou E by dou T, and del cross H is equal to J plus dou D by dou T, with D is equal to epsilon E and B is equal to mu H. These are the 4 Maxwell's equations. In terms of magnetic vector and scalar potentials, these 4 equations can be written as del square A is equal to minus mu naught J and del square phi is equal to minus rho by epsilon. These are the 4 Maxwell's equations in terms of electric and magnetic field vectors. These are the Maxwell's equations in terms of magnetic vector and scalar potential. So we consider these terms because we have already calculated the 4 vectors of A, that is A1, A2, A3 and A4, and we also calculated the values of J1, J2, J3, J4 is I0. So it is easier to solve these Maxwell's equations in terms of magnetic vector and scalar potential. So now consider these Maxwell's equations in vector and scalar potentials. These will be satisfied only when the Lorentz condition, so there are some terms called mu epsilon dou phi by dou t, extra terms are there. If the condition divergence of A plus 1 by c square dou phi by dou t is equal to 0 only satisfied, then these two are the Maxwell's equations form. So these 2 conditions must satisfy the Lorentz condition. This is the condition. So our aim is covariance of Maxwell's equations, that is in 4 vector form. In the previous class we have derived these 2 as del square AU is equal to minus mu naught into JU. So what are the values of U? U is equal to 1, 2, 3, 4. In 4 vector we write these 2 equations as del square AU is equal to minus mu naught JU, and we have also write down the Lorentz equation in 4 vector form as dou AU by dou XU is equal to 0. These 2 are the Maxwell's equations in 4 vector form. This is the Lorentz condition in 4 vector form. So our aim is how they are invariant. So invariant means, let us consider another frame of reference with magnetic vector potential AU dash and delta AU dash by dou XU dash. So del square del dash square AU dash is equal to del square AU. So if you prove these 2 equations are same, then we can say that the Maxwell's equations are invariant under transformation. And we should also prove that this these two equations are also one and the same. Then we can say that with Lorentz condition, the Maxwell's equations are invariant. So our aim is to calculate del dash square AU dash is equal to del square AU, where U is equal to 1, 2, 3, 4. So before that, first remember the values of A1, A2, A3, A4 dash. So what is A1 dash? In previous class we have derived this is A1 minus V by C square into 5 by root of 1 minus beta square. A2 dash is same, A3 dash is A3, A4 dash is A4 minus of I beta into A1 by root of 1 minus beta square. So these are the magnetic vector potentials in another frame of reference. So from the last equation, so we have also find out phi dash. Phi dash is equal to 5 minus V into A1 by root of 1 minus beta square. So remember these 4 terms. And also similarly J1 dash. So J1 dash can be calculated as Ju dash into alpha uv into Jv. So calculate this Ju dash. As you know that alpha uv is gamma 0 0 I beta gamma 0 1 0 0 0 0 1 0 minus I beta gamma 0 0 gamma. So calculate, it is your work, and find out what are the values of J1 dash, J2 dash and J3 dash and J4 dash. So what is J4? I0. So then substitute. Please find out these values from this Lorentz transformation, and finally we get J1 dash is equal to J1 minus V rho by 1 minus beta square. J2 dash is same J2, J3 dash is J3. These are simple. So just substituting the matrix and find out those terms. And J4 dash is J4 minus I beta J1 by root of 1 minus beta square, or simply rho dash is equal to rho minus V by C into J1 by root of 1 minus beta. It's not a toughest one. So find out, this is the work I will give in to you. So this is J1 dash. Find out the values of J1 dash, J2 dash, J3 dash and J4 dash. From this condition you will get the same things. So remember these 8 equations. Then first, del square AU is equal to, our aim is del dash square AU dash is equal to minus mu naught into JU dash. So this is our aim. So let us take the first one, that is del dash square A1 dash. Since del dash square is equal to del square, so in all the calculations I am taking del dash square as simply del square A1 dash. So del square, what is A1 dash here? A1 minus V by C square into 5 by root of 1 minus beta square. So this is 1 by root of 1 minus beta square into del square. So multiply this del square with these two terms, that is del square A1 minus V by C square is constant and del square 5. 1 by root of 1 minus beta square. What is del square A1? Minus mu naught into J1 minus V by C square into del square 5 is minus rho by epsilon naught. This is 1 by root of 1 minus beta square minus mu naught J1 minus rho by epsilon naught is C square mu naught is mu naught minus mu naught into minus into minus plus V rho. So this del square del dash square a1 dash is equal to del square 1 by root of 1 minus beta square. Take the minus mu naught as common, so j1 minus v rho, so minus mu naught j1 minus v rho by root of 1 minus beta square is j1 dash. So del dash square of a1 dash is equal to minus mu naught into j1 dash. That is, the first invariance is verified. Hence, in the two inertial frame of reference, the first Maxwell equation is satisfied. And the second Maxwell equation, what is the second Maxwell equation? Del square del dash square a2 dash. Del dash square is nothing but del square and a2 dash. Since a2 dash is equal to a2, this is del square into a2. What is del square a2? Del square a2 is minus mu naught into j2. Since j2 is equal to j2 dash, this can be written as minus mu naught into j2 dash. So we have verified the second equation. Next, third one is del dash square a3 dash, that is del dash square and del square are equal, and a3 dash. Since a3 dash is equal to a3, so del square a3. What is del square a3? Minus mu naught into j3. Since j3 is equal to j3 dash, this is minus mu naught into j3 dash. Simply all are verified. And last one is del square a4 dash is equal to del dash square a4 dash is del square a4 dash. So what is a4 dash? Del square a4 dash is a4 minus I beta of a1 by root of 1 minus beta square. This is 1 by root of 1 minus beta square del square a4 minus I beta into del square a1. What is del square a4? Minus mu naught into j4 minus I beta gamma into del square a1 is minus mu naught into j1. So minus mu naught, take the common, minus mu naught root of 1 minus beta square. So from this term minus mu naught is common, the remaining term is j4, minus is common, minus I beta into j1. j4 minus I beta j1 by root of 1 minus beta square is j4 dash. We got minus mu naught into j4 dash. Thus all these four equations, that is del square del dash square a1 is equal to minus mu naught into j1 dash, and del dash square a2 dash is equal to minus mu naught into j2 dash, del dash square a3 dash is equal to minus mu naught into j3 dash, del dash square a4 dash is equal to minus mu naught into j4 dash, are combinedly written as del dash square au dash is equal to minus j naught into ju dash, where u is equal to the values from 1 to 3, 4. So the same equation in S inertial frame of reference, del dash au is equal to minus mu naught into j. So the Maxwell's equations in terms of electromagnetic potentials are invariant under Lorentz transformations. By satisfying the Lorentz condition. What is the Lorentz condition? In 4 vector form, dou of xu by dou of AU by dou XU is equal to 0. That is dou A1 by dou X plus dou A2 by dou X2 plus dou A3 by dou X3 plus dou A4 by dou Y is equal to 0. Similarly, we should prove that dou AU dash by dou XU dash is also 0. Then these two are invariant. So simply this derivation is very simple. So AU dash is, what is AU dash? Alpha UV into AB. So here alpha UV is nothing but dou XU dash by dou XV into AB. So this is the actual calculation of alpha UV. Remember that alpha UV is dou XU dash by dou XV. So let us calculate. So in order to derive that, let us differentiate this equation, that is dou AU dash by dou XU dash is equal to dou by dou XU dash of dou XU dash by dou XV into AB. Dou XU dash cancel, we got dou AV by dou XV. What is dou XU by dou V or dou AV by dou V are 0. So these two equations are satisfied, hence the Lorentz condition is also invariant under Lorentz transformation. This is regarding the invariance and covariance of Maxwell's equations by satisfying the Lorentz condition.